Hello and welcome to the official monthly podcast from Kielder Observatory, situated in the Northumberland Dark Sky Park in the UK, under some of the darkest skies in Europe. I'm Ian Brannan and I'm joined by the observatory's science lead this month, Ellie MacDonald, and education lead, Adam Shaw. And in this episode, the theme is fire and ice and the volcanoes of the solar system. Our special guest is Dr Natalie Starkey, a cosmochemist and author, who joins us to talk about some of the amazing findings from her new book called Fire and Ice, and how volcanoes could be key to supporting life in other worlds.
A volcano tells us that that world is geologically alive, and we think that's necessary to create a life-giving world. So we need some kind of heat within that world that keeps it moving geologically. So we basically can melt rock or melt ice. And then the reason that's important is because that gives us the chance to have an atmosphere and to have liquid water somewhere within that world. It's a good sign that something's going on, and then we can kind of take the next steps to investigate those worlds in more detail once we know they've got active volcanoes.
It's a fascinating chat, and we'll learn how not all volcanoes erupt with fire, some with ice. Plus, we'll learn why some of the biggest unsolved mysteries of the solar system are right here on Earth. Plus, we'll also update you on what's happening at Kielder Observatory before the end of this and have a look ahead to some of the things that you can look out for in the night sky, wherever you are, whether you're in a dark sky park or just in your back garden. All to come on the Kielder Observatory podcast. To our special guest in this month's episode of the Kielder Observatory podcast, and that is Dr Natalie Starkey. Now, Dr Natalie Starkey is a cosmochemist. Her research combines space science and geochemistry, analysing comets and asteroids to probe back 4.6 billion years into the early solar system to understand where everything came from. And she's also an author too, alongside working with the Open University. Her first book, Catching Stardust, Comets, Asteroids and the Birth of the Solar System, came out in 2018, and her newest book was released in September this year, and it's called Fire and Ice, the Volcanoes of the Solar System. And that is what we're going to talk about now, because that is a specialist subject of Natalie's, as you can well imagine, and certainly something that she studied over many, many years and has been all around our planet looking at volcanoes. But it's volcanoes in other worlds that also interest us too, and we'll find out why they themselves are important throughout the course of our conversation. But first of all, my great pleasure to welcome to the Kielder Observatory podcast, Dr Natalie Starkey.
Hi, thank you for having me. I'm excited to be here.
Well, we're excited to have you with us. And first question is, why volcanoes? I mean, they are fascinating things here on Earth, but what took you on a journey to explore volcanoes in other worlds, elsewhere in our solar system and beyond?
I've absolutely just always been fascinated by volcanoes from quite a young age. I remember at school learning about Catcher and Maurice Craft, who were these two volcanologists who basically travelled the globe whenever they heard about a volcanic eruption happening, whether it be Japan or Italy or wherever it was, jumped on a plane and basically went to document in film and photography the volcanic eruptions, the physical mechanisms of what was happening with those eruptions. And their work is just absolutely amazing. And it's those images that you would have seen at school, you know, back in the 80s and 90s through to the 2000s, like we saw loads of their images and they're so iconic. And if it weren't for them, we wouldn't have known at the time so much about volcanoes, because you've got to remember, we didn't have drones and things like that at that point. You know, with the recent Icelandic volcano, we've seen all that amazing drone footage so we can get up close, but we couldn't do that in those days. So for me, like knowing that they went out there and, you know, literally risked their lives to get this footage was amazing. And it really stuck with me. I didn't know, you know, that I could even be a volcanologist at that stage or what I might be doing with my future. But it really inspired me to think, wow, that's a really exciting job. You know, how, you know, jumping on planes and chasing volcanic eruptions, it just seems like not a real job, doesn't it?
It's a job you enjoy, and that's got to be a good thing. Volcanoes are fascinating. Do you know why that is? Is there something that you can put your finger on about volcanoes? I mean, my daughter's 5. She's never seen an actual volcano in real life, but she can spot a volcano in a photograph a mile away, and maybe she's a budding volcanologist. Who knows? But Is it the mystery of we don't know what's going on inside these mountains, and the mystery of stuff coming up from inside the earth and spewing out as lava from the top? What is it about volcanoes really that really gets us?
Yeah, I think that's the thing. We get those big eruptions which happen fairly infrequently, but the ones that produce the massive ash clouds, which are hugely destructive, and actually with large eruptions that push a lot of ash up into the atmosphere, that can create damage throughout the whole planet, essentially. It can create cooling over our climate for a years following a large eruption, and obviously cause complete devastation to the local populations. But then we get these sort of smaller eruptions, what we call effusive eruptions, which is what's happening on La Palma. And it seems very exciting and explosive, but it's hot rock, molten rock spraying out of a volcano. It's very exciting to watch. But it's quite a localized thing. So it's not going to be affecting islands around it. It's literally just affecting the local population on La Palma or wherever that volcano is going off. But that's great to watch because as a volcanologist, as a geologist, you're seeing the birth of the Earth's youngest rocks, literally just spraying out of a volcano and then, cooling down as they set on the ground. And so, that's all part of our planet being alive inside, and the fact that it's, got this hot interior and it just needs to lose that heat. And volcanoes are simply just one of those mechanisms that the Earth chooses to cool itself down with.
So yeah, we've been in schools all week and we've been talking to kids particularly about things like exoplanets, and we've been talking about moons, and we've been talking a little bit about cryovolcanoes, but I'm not sure if me and Adam really know what they are or exactly how they work. So I was wondering if you could explain a little bit about how cryovolcanoes work.
Yeah, we have loads of cryovolcanoes in the solar system. In fact, they're almost just as common as the hot volcanoes that we see on places like Mars and Venus and Earth. Now, they're essentially the same. So we've just got to remember that when we go out to the outer solar system, these worlds are made of ice. So their crusts are made of ice, whereas on Earth, our crust is made of rock. So when you melt that material, when you melt the bedrock of those worlds, it's not, the lava is not made of rock or molten rock. It's made of, liquid water or methane or ammonia or whatever these ices are, the ices that exist on these worlds. If we melt them, that's their lava or their magma. So actually, cryovolcanoes are just a different type of volcano, but they can react in the same way to being heated up as anything does on Earth. So if you've got warmth inside one of these worlds, and actually most of these icy bodies in the outer solar system have a rocky interior, just like our own planet. And if that rock is heated up and, puts heat out into those worlds, then what we can create is volcanic activity at the surface. So if we take Enceladus as a great example, because we've seen it happening, we've got these plumes of ice shooting into space, and it comes from underneath its crust of ice. It's got this global salty ocean sitting above this rocky core. So we could actually call this an ocean world as opposed to an icy world. It's icy as well, but it's got this huge ocean underneath, and the activity in this ocean creates these plumes that shoot out. Now we've actually flown through those. The NASA Cassini mission flew through them and basically tasted what was in these plumes. So we know there's salt, which comes from the salty ocean, and we know there's these nanosilica particles. Now these are really important because they tell us that there's reactions happening at the base of Enceladus's ocean, reactions happening between the core, the rocky core, and the salty ocean. And we've also detected organic material within there. So we've got carbon and hydrogen stuff in there. Now we haven't detected life, but hopefully there's going to be a mission going back in the future to actually look whether there's life in these plumes. We've got to remember when Cassini set out, we didn't even know these plumes existed. So it was just by chance that they were able to detect some stuff within them. So this volcanic world is so exciting. It indicates to us that it's alive inside this world, geologically speaking. And the next thing to look for is, okay, if is it a life-giving world, basically? Does that heat support anything else other than that volcanic activity?
I think as well, we've spoken about the potential search for life, particularly with exoplanets over the last year or so. When we've been doing this podcast, we've had a few guests that have mentioned that as we get better at looking deeper into the universe, of course, the James Webb Telescope will provide a greater insight into parts of the universe that we've not been able to see before. And when we're talking about life, obviously this could be microbial life. What relation does finding a volcano potentially equal to finding life? Is that a sign that life may well exist?
Yeah, it's sort of one of the first things we'd want to see. A volcano tells us that that world is geologically alive, and we think that's necessary to create a life-giving world. So we need some kind of heat within that world that keeps it moving geologically. So we basically can melt rock or melt ice. And then the reason that's important is because that gives us the chance to have an atmosphere and to have liquid water somewhere within that world. Now, Earth is the only planet we know of that has liquid water on its surface. And it also so happens to be the only planet with life that we know of. So we do think that these two things could be connected in some way. But Earth is not the only place to have water, as we know, and importantly, liquid water. So we've got Europa, Enceladus, and probably many of the other moons of the outer solar system all have liquid oceans underneath an icy crust. Now, that's not surface water, but that doesn't mean they couldn't represent an environment that life could be thriving. So yes, volcanoes tell us that we've got something geologically interesting, and then we have to jump to the next step and go, what does that tell us about the rest of that world? Does it have water? Does it have a magnetic field, which Earth also has, and it protects us from space radiation? It's another really important thing for life. But if we go to Europa, maybe it doesn't need a magnetic field because life could live in the ocean protected from radiation under this thick icy crust. So basically we've got, it's a good sign that something's going on, and then we can kind of take the next steps to investigate those worlds in more detail once we know they've got active volcanoes.
When you think about other moons in the solar system, there are some really, really fascinating moons, but I'm a bit interested in our own moon as well. Do we know much about any previous geological activity within the moon, any previous volcanoes, and whether or not they might be able to pop up again if the moon might be able to, our moon might be able to become geologically active again?
Yeah, so the great thing about our moon is that it's a really useful body to look at to tell us more about our own world, in fact. So the moon formed from the Earth over 4 billion years ago. And since then, because it's small, it's sort of cooled down a lot quicker than our own planet. So very broadly, size is quite important in the solar system to control how quickly or slowly something cools, and therefore its potential to host life or water or things like that. So Earth is sort of the perfect size, let's say, to create life. It didn't cool too quickly. It's still got plenty of heat within it. So the heat within our own planet is in the core, and it's also within our mantle and crust. We're actually sort of like a nuclear reactor. We're always generating our own heat through radioactive decay of elements within our mantle and core. So we've got plenty of heat to lose, and that comes out in volcanoes. Now, the moon, obviously being much smaller, it lost that heat a lot earlier. So all of its volcanic activity died out by around 3 billion years ago, sort of the major amount of activity. Obviously, you've got to remember the Earth and the moon are about 4.5 billion years old. So it was still active for a very long time. And I think it's always tricky with geological timescales to kind of get that in your head. But yes, the moon was really, really active for quite a long time. In fact, if you just look up at the moon, even just with the eye, you don't even need a telescope to see this, but there's lots of beautiful images out there as well of the moon. Those dark patches you see across the moon are in fact called the mare. Now, this means sea in Latin, and that's because the first astronomers that looked up thought that these mare were oceans of water on the moon. Now, obviously, we now know that the surface of the moon is dry, and those dark patches actually represent huge lava flows. So they fill these big basins, which were probably formed by asteroid and comet impacts in the moon. So these volcanoes erupted and their lava flowed to fill these basins, meaning the lava was really, really runny, different to what we would see on Earth a little bit. So there's loads and loads of lavas across the moon, but there's also evidence for explosive activity as well, not in the form of a big kind of ash cloud volcano, but we see what kind of the fire fountain eruptions like we've seen on La Palma just recently. And these are in the form of glass beads. So some of the Apollo astronauts found glass beads on the moon, that it's in these soils, and they're very small, literally formed of glass. And that's because when lava sprays out of a volcano, it's got loads of silica in it. That's one of the main components, one of the main elements in lava, and that's obviously the same as in our glass and our windows. So if you cool silica really quickly, it forms a glass. And so we have these glass beads, and they're orange in colour, some of them, which is really cool. They've got different elements within them. But it shows us that the moon had this really explosive activity. About the fire fountains are thought to be around 3.5 billion years ago. So it's all pretty much dead now. We don't expect there to be any more volcanic activity on the moon, but it could happen. Like, it might be, the moon is not completely cold inside. So there is sort of a really unlikely chance that it could have some activity in the future, but it wouldn't be on a large scale like we've seen in its past. So yeah, we can use the moon to tell us a lot about kind of what's happened in our history as well. It's a really, really important place to go. And I think, yeah, we need to go back and look at more of the moon's surface, because we've really only visited quite a small portion of it so far.
I've never heard about those glass beads from the Apollo mission either. I think that's definitely something I'm going to have to research after this session.
Yeah, it's actually Harrison Schmitt, who was the Apollo 17 astronaut. He was one of the ones, and I'll just note, the only geologist to go to the moon. So, you know, it's all about fast jet pilots, but no, we need scientists to go out and explore space, because he spotted these weird orange soils when they were on their way back to the lunar module. They had like just not much oxygen left, and NASA were getting a bit angry that they weren't getting straight back. But he, you know, was like, I need to sample this rock, because, you know, he's a geologist, that's what we do. And thank goodness he did, because he found, you know, these amazing samples, and luckily they didn't run out of oxygen, so thank goodness.
Oh, that's amazing. And, yeah, as I say, fascinating. Makes it even more exciting for the Artemis program then, sending humans back to the moon, I suppose.
Yeah, definitely. I think that's one of the things, you know, robots are great for exploring space, and particularly when we're going somewhere new where we know nothing about that world, and, you know, we can send these robots out and they can do that dangerous kind of first exploration for us. But, you know, humans, we can't beat humans' intelligence and, you know, just, you know, the way that we can see things and move across terrains much quicker. Like, we are the best to do the exploration, but obviously we can't put people at risk. So when we're talking about exploring Mars, you know, I think there are huge obstacles to overcome. But of course, I think getting back to the moon should be a little bit easier. I don't want to say easier, because it's not easy, but yeah, I think that's a good first step.
I mean, jumping over to Mars, however, and in particular with Perseverance. So Perseverance landed on Mars just last year, and one of the big things which it's doing for the first time is taking samples of rock that hopefully we'll pick up. Are you particularly excited to get those samples, or to, I don't know, research them, hear about them in a bit more detail? Do you think it'll tell us anything about Mars's volcanic past?
Yeah, so in terms of sample return, like, a lot of people won't realise that we don't have any samples from Mars that we've collected. So we've done that on the moon with the Apollo era and all of that. So we have plenty of moon rock, although we'd always like more. But with Mars, the only samples we have on Earth from Mars came as meteorites from the surface of there. So basically, Mars was impacted by an asteroid, it threw up pieces of rock into space, and eventually they came on a collision course with Earth. Now, the problem with meteorites is that they can be altered during this process, and we don't know exactly where they came from. So we have to kind of piece together all the chemistry of that rock to figure out where exactly it came from, which planet first of all, or asteroid, and then, you know, where on that planet we think it came from. So going somewhere and actually returning samples is just so important for the science. It allows us that real ground truth of, like, this, we know this rock is from Mars. It hasn't been altered during atmospheric entry. And then we can compare it to all the rocks that we have on Earth, you know, that we think are from Mars. And it's, yeah, so the value of that is great. And I think, you know, everybody is very excited about getting back those samples in the next, you know, decade or whenever it is. Of course, sending humans to collect those samples would be the next step, and that would be even better. But the fact that a robot has collected something and NASA have confirmed there's some kind of sample in there is great. So yeah, I think the importance of these samples is really to understand, the main idea of that mission is really to look at the habitability of Mars, but equally that all feeds into the history of the planet as well. So, you know, the fact that we we pretty much have evidence that Mars had volcanoes erupting underwater. And we can detect that from space by kind of some of the mineralization that happens during this process in the rocks. And that tells us that we had this really important environment of hot rocks and erupting rocks into salty water, probably salty, it might not have been. And this is a really important environment for life. So this is one of those places that we'd want to go and look at and find more about, to kind of look into that history of Mars and trying to figure out if, microbes existed. I'll just point out this environment's really similar to what we have at the bottom of our oceans. So along the mid-Atlantic ridge, for example, Iceland, it runs through Iceland and carries all the way down through the Atlantic. We've got two tectonic plates pulling apart. And this is where new magma is always bubbling up and filling that gap. Now, these environments since the 1970s, we've known have been really important for what we call extremophiles, these really weird bugs, which we just didn't understand how they could survive down at these depths. There's no sunlight. They literally create energy through chemical reactions. That it's just really weird, and it's life but kind of not as we know it, let's say. And so it's these environments that we can compare to places like Mars and underwater volcanoes on Mars to try and think about what life might look like there. It's not going to look like us, but it might look like kind of the microbes that are at the bottom of our ocean. So sorry, really long answer, but there.
Yeah, wonderful answer. Thank you very much. I mean, Mars is just absolutely fascinating. I think one of the I loved volcanoes growing up, so one of the first things that got me interested in space even was learning about Olympus Mons. Like, obviously, great big volcano, of course I was going to be interested. But how did it get quite so big? Because we don't have anything that big.
Olympus Mons is a great one. So it forms in the same way as actually Hawaii. So if we take Hawaii as a really good example, it forms because of what we call a mantle plume. So this is essentially a hot chimney of rock that rises up through the Earth or through Mars from very deep within it, probably like the core mantle boundary in Earth, that's like 3,000 kilometers depth. So these are huge chimneys of rock. When they get to the surface, they start erupting rocks as lavas. So on Hawaii, we see that now. That activity is on the big island of Hawaii. But what happens on Mars is that it doesn't have plate tectonics. So you've got this mantle plume sitting in the planet. And on Earth, the plate continues to move over the top because our plates are always moving. And so basically, you've got that island chain of Hawaii, which is about 5 or 6 islands that go from northwest to southeast. And the current activity is in the southeast. Now on Mars, it hasn't got plate tectonics, so that mantle plume just sits in the same place and erupts forever onto the same spot on the crust. So what happens is these lava flows build up and it creates this bigger and bigger mountain. And I think the Olympus Mons mantle plume was active for nearly 1 billion years. So we've got like so much activity just happening in that one spot. And it's created this volcano that's 25 kilometers high, which, that would collapse under its own weight if it was on Earth, because we have more gravity on our own planet. It just couldn't survive here. But equally, it wouldn't happen because our plates are always moving. So we create chains of volcanoes. But yeah, Olympus Mons is not the only one. There's actually, it sits in a line with about 3 other really large volcanoes as well, all formed by mantle plumes and not kind of related tectonically as they would be on Earth. So it's, had a really long history, and it may have also had super volcanoes erupting on Mars very, very far ago in its past, kind of much earlier in the older terrains. We see evidence for big craters that might have been formed by super volcanic eruptions like Yellowstone or something. So there's a lot to learn about Mars still.
I mean, do we know why we have plate tectonics but Mars doesn't, or other places don't? Do we know why we've developed this, or?
We don't have a good answer at the moment for that. There's lots of ideas. So the way to get plate tectonics is that we need to have a brittle crust. So it's got to have cooled enough to be brittle enough to break, but not cooled too much that then the inside of that planet is not capable of convecting and moving material around. So sort of the mantle that I've mentioned of Earth It's a huge region of our planet, and it is solid, but it can convect like a fluid. So it's really hard to explain how it moves. But one of the ways I tend to describe it is kind of like if you go on a hot day and you see the cars on the road and the tarmac is sort of squished a bit under the tyres because it's such a hot road. It's sort of like that. It's a solid, but it's able to move. So the way we think that we created it is that we cooled just at the right rate, that, you know, we had that brittle outer portion of our planet, but the inside was still warm. Now, we think Mars maybe cooled just too quickly, that it couldn't ever create that. We also think water's quite important to sort of lubricate the process and create, you know, kind of the plates can kind of sink below another plate in a process called subduction. So we're not sure. Venus looks like it should have all the right ingredients for having had plate tectonics, but we think it's too hot now. So its surface might be a bit like Play-Doh. It's just too squishy, so it can't create those brittle plates. We don't know in the past if it did have it though, because the surface of Venus today, it's all about the same age. It's about 500 million years old, which sounds really old again, but remember we're talking billions of years time scale for the age of Venus. So actually we don't know what happened to Venus before that. We don't have its geological history preserved in the same way that we do on Earth. So, you know, investigating these worlds can be very complex. And so, yes, we don't have an answer for that. But actually, I'll just mention Europa might have some sort of plate tectonics, but we're talking ice tectonics, I guess. And its ice is in places broken up into pieces that seem to act a bit like plates do on Earth. So yeah, we've got to just, you know, change our minds and think about ice then.
Cool. I think that's Europa, I think, is Adam's favourite moon, I believe. So
it's definitely one of my favourites. It's fascinating. I'm really excited for the different space probes, NASA's and European Space Agencies.
I know, and it's launching next year and in a few years. So we're going to have a lot of information about Europa and its neighbour moons soon, which is going to be great.
Earlier this year, when the Juno spacecraft got some close-up photos of Ganymede, and I think it's a couple of years until it's going to be doing a flyby of Europa, but I'm really, really excited for that.
Yeah, and I think that's one of the things about solar system exploration, as opposed to, we were talking about exoplanets earlier. The thing about solar system exploration is it's all about imaging. Like the first time we ever go out and look at stuff, we're going to get images because they're so informative about the geology of those worlds. We can look at the landforms and how craters relate to lava flows, and it tells us so much about the evolution and history of those worlds. Now, we can't do that with exoplanet worlds. So we only rely on data. So that might be from a spectra. It might tell us a little bit about what's in the atmosphere of that world, but we don't have, you know, images to inform us about what they look like. So it's a very different ball game when we're talking solar system science. And I think, you know, it's useful for solar system stuff because we have beautiful images, and, you know, every time we go back to worlds, we get a higher resolution image. We reveal more information about those surfaces. So yeah, I'm really excited about all these future missions.
Yeah, see, from a human perspective as well, I think the image is just incredibly important for us to be able to kind of get captured into seeing these other worlds. So that's why I like Saturn's moon Titan as well, because it has this thick atmosphere, and when you peer deep below the clouds, it looks like how you imagine an alien world would be. But if we are talking about favourites, you know, whether it be favourite moons, I've got a question then. What's your favourite volcano, if you have a favourite, whether it be on Earth or anywhere in the solar system?
Yeah, easy. It's going to be on Earth actually, and it's the Soufriere Hills on Montserrat. It's just because I've worked there and I love the island. It's a British overseas territory. It's a very small island, and it's next to Antigua. It's about 10 kilometres long by about 4 kilometres wide. And it's almost this, despite the volcano, this kind of unspoilt place. It's just beautiful. It's the people are amazing that live there, and they've learnt to live with this massively active volcano, which takes up pretty much the bottom third of the island, and it's a big exclusion zone. But you know, when that volcano kicked off, loads of people had to be moved out of the capital of Plymouth, which was right next to the volcano. And thank goodness they were evacuated in time, because it went off really, really big and, you know, covered that whole island, that whole portion of the island in ash flows and everything. So it's an incredible place, and also really fertile. So they grow amazing fruit and vegetables there, because that ash that rains down, actually, when you work that into the soil, soil. It works as a great fertilizer in soil. So they've got loads of markets where you can get, fresh guava and mango and all these beautiful fruits. And yeah, it's just a beautiful island. Now, it's always going to be this kind of volcanic activity taking place there. But you can visit the island. It's still kind of safe to visit. And it's basically just that bottom portion that you can't really access very easily, except if you're on a special tour when it's not active. But yeah, that's definitely my favourite.
Admittedly, I hadn't heard of that one before, so I did literally just Google it as you mentioned it, and seeing some of the photos of it. I think I found an image of it erupting in 1997, and that's that's exactly how you imagine a volcano to look, just lava flowing down the side of it.
It's a classic.
Yeah, absolutely. But I can also kind of see what you mean about when it's not erupting, when there's not kind of ash everywhere, make it all look gloomy and like something from Lord of the Rings, Mount Doom, or whatever. It's a very green island. It looks absolutely beautiful there.
Yeah, it's a really, really gorgeous place. Hard to get to because you have to, they used to have a boat that went there and then you had to get a small plane, and it's a bit of a hairy journey because the landing strip is quite small. It's tucked between two mountains, which seems a little bit, not the cleverest idea, but it makes it fun. It feels like an adventure trying to get there.
On that subject about the how the ash from a volcano really changes the plant life and so on. There's a study that has been done by Birmingham University about how the volcanoes really changed plant life and allowed dinosaurs to evolve. And because of the changes, and particularly high mercury coming out of a volcano has changed the plant life, and that allowed dinosaurs to take that leap from sort of small creatures into the big, massive creatures that we know. And it looks like scientists are now putting the evolution of dinosaurs down to volcanoes.
Wow, that's amazing. I haven't heard of that. I'll have to look that one up.
Head of the curve.
Yeah, thank you. That's really cool.
It's Jason Hilton from the University of Birmingham. And it's in the New York Times, and it was a few days ago in the New York Times. But yeah, saying that how the amounts of mercury increased in line with when they think the volcanoes erupted. So and that's made a difference to the plant life and really changed the plant and the minerals in the plants, allowing the dinosaurs to evolve over millions of years.
And that's the thing. We always think, when volcanoes erupt, it's just, the heat coming out from the planet, but it's also everything else that's within our planet, the gases that are stored within there and all the other elements that are kept within our mantle, which were there from, when the planet was formed 4.5 billion years ago. It's all that stuff coming out. So, it kind of replenishes our planet with new materials. And actually, one of the cool things related to plant life on volcanoes is that whilst it looks very inhospitable, the surface of a lava flow, of course, when it's hot, it really is inhospitable. But very quickly, plant life can make a lava flow its home. And one of the great examples is on Hawaii. You see these black rocks which have no soil, and little plants are surviving just within cracks within those rocks. And they're specially adapted to survive, at the altitudes that the Hawaiian volcanoes sit at. And they've got beautiful berries on them. And it just shows you that actually, life will find a way. It seems like an inhospitable place to live, but these plants make it their home. And then those plants actually sort of make that flow a bit more stable. And then more life it draws more life to that region. So there's this whole thing about studying, biologists can study volcanic worlds and volcanic landscapes to look at how they get inhabited by species over time. And that's a fascinating area to look at as well.
And in addition to providing nutrition or whatever it was in the food, in the plants, volcanoes play a big part in altering our atmosphere. And particularly back in the era of the dinosaurs, volcanoes erupting around the world would have quite a significant impact on the climate of Earth as a whole.
Yeah, completely. So they can release a lot of gases. So the ash, first of all, can encircle the globe and block out the sun. And so that can have a short-lived effect on the climate, maybe a year, maximum of 2 if it's, quite a big eruption, potentially longer if it was a super volcanic eruption, but they are very infrequent. So that can have a cooling effect. And actually that's happened quite frequently. after some of the big eruptions in human history. I think it was the summer of 1816. Now I'm going to get this probably wrong. I think it's Krakatoa. I always get confused. There was two that year, Krakatoa and Tambora. But anyway, I think it's Krakatoa 1815. But the following summer was known as the year without summer. Because basically there were frosts throughout Europe and in the summer months, and also kind of northern America, and it meant that crops couldn't grow, and it created famines in that kind of summer because it blocked out the sun. But we've also got the aerosols that are released from volcanoes, and so these are all the gases that come out that can have a similar effect and can also change sort of the skies. We can get red skies as you see kind of it changes the way sunlight filters through the clouds. So they can have a lot of effects, but actually we can't blame climate change on volcanoes. Actually, the amount of gases, particularly, if we're talking about carbon dioxide, that they release is nothing in comparison to the human effects. So actually they can have a cooling effect more than they can have a warming effect, let's say. So yes, I'm not saying we want to go and cause volcanic eruptions to happen to get ourselves out of climate change issues. It's not going to work. But, we can't blame volcanoes for that. But on Venus, we don't know. It might have been on Venus that volcanoes are the reason it's now incredibly hot with this really thick carbon dioxide rich atmosphere. That's something we're going to be investigating with future missions to Venus because, it could have been the volcanoes that actually created that horrible environment on its surface now.
If you could visit a volcano in space and survive, obviously, which would you pick to visit? What would you want to see yourself?
I'd definitely go to Io, which is a moon of Jupiter. It's the only rocky moon in the outer solar system in terms of rocky on its surface. And it's the most volcanically active object out there. So actually the Voyager missions were the ones to first fly past, and in the 1970s, and they saw 9 eruptions between them just in 2 flypasts. So it's extremely active, and actually we think there were other eruptions in between those 2 flypaths. So the thing about Io is it's got lava lakes, it's got eruptions happening all the time, these big plumes shooting into space. And its surface is literally just a volcanic world. It would be so fascinating to look at. And it would actually, it's kind of similar to what we think Earth was like 4 billion years ago. So it can inform us about how our own world sort of evolved and how those volcanoes erupted. But yeah, I love lava lakes. They're great. We have a few on Earth. They're not particularly common. But I saw the one at Kilauea just before it erupted in 2018, and they're just fascinating to watch. See that lava literally bubbling up within a lava lake is just fascinating. So definitely Io, if I could survive there.
We mentioned at the start of this that as well as volcanoes, you have a great interest in the birth of the universe and the early unanswered questions. And some of those questions actually are not elsewhere in the solar system. They're right here on Earth. And one of them being, how did we come to have so much water? Where did the water on planet Earth come from? And unbelievably, this is one of the big questions that still largely remains unanswered about our planet.
Yeah, so one of the weird things is that we've got all this water on our surface, but we don't actually have a good explanation for where it came from. We've got lots of ideas. Now, it could have been there right from the beginning when our planet formed. Now, within interstellar space, where we create our stars and our planets, there is water, and it's in the form of ice. So we know there's plenty of water in our galaxy. Now, the problem is when we form a star and then all the material around that star and that cloud, it gets quite hot and it's quite a violent time. And we're just not entirely sure how ice and water itself can survive that process. But if it does, maybe it dissociates and comes back together in this molecular cloud around, or a circumstellar cloud around the star. We then start to form planets out of everything that's there. So, okay, there's water there, hopefully, and then that gets incorporated into these growing planets. But then as planets grow, the process of doing that is very violent and it's very hot. So we think if we have a ball of magma, it could have dissolved water within it. But actually, is it going to stay dissolved if this body is at 1200 degrees Celsius? I mean, probably not, but then we definitely know there's water inside all of the planets, so it's got there somehow. So, okay, maybe it can survive that process. And so the water that we have is like this interstellar water. But the other option is that it all boiled away during that process and we had dry planets that were then kind of seeded with water and other elements later on. And this seeding came from the comets and the asteroids. So we know that about 4 billion years ago in particular, all the planets were bombarded with comets and asteroids. It was a bit of a crazy time during solar system formation. And these impacts would have brought in with them bits of, all the bits of the comets and asteroids that contain water. And they could have then been dissolved within the planets as they were cooling down, as it was getting a little bit safer in the solar system, let's say. So it might be that our water comes from comets and asteroids, or it might have been here from the beginning, or it might be the case that it's a bit of a mix of those two things. But the chances that our water is as old or older than the solar system is quite high, that we are actually drinking, interstellar water. I mean, everything came from the interstellar space initially, but it's, whether it stayed in the planet from the beginning. So it's a big question we're trying to answer. And one of the reasons is because we're the only place with liquid water at our surface, and because we think that's related to life on our planet. So we want to go out and understand where we can get liquid water elsewhere and where it came from. And this includes looking at exoplanet worlds, that when we're looking for them, can we see water in their atmospheres and surfaces? Where did it come from? And does it mean that there could be life? So it's, the question of where water came from is such a big topic. And it's crazy that we don't have an answer yet. I love that this is like one of those unanswered questions that that keeps us going as scientists.
Earth is very special in terms of everything happening just right to give us the conditions for life. And that, of course, is something that so far we haven't found anywhere else as yet. But do you think that the same conditions or similar conditions that we have here on Earth do exist, and that we obviously know that volcanoes exist? Do you think that we will find life elsewhere sometime?
I'm pretty sure there's life out there somewhere in the galaxy, because there's just so many stars and planets that are out there. But so far, we haven't found anything Earth-like. Now, do we need to be Earth-like for life? That's the question. And the reason we think yes is because we haven't found life anywhere else. But, as soon as we do, and I'm saying as soon as we do because I'm sure we're going to, it then opens up, the data set. We're like, oh, we have now 2 places with life. And how different are they? What do they have that's similar to each other? And then we start to work out the key components that are required to create a life-giving planet. But, Earth is very special. As I said, it cooled at the right rate. It's created this beautiful atmosphere. It's got this magnetic field that protects it. So we know that life that is based like carbon-based life that has, cells like us needs all of those things to survive. So who knows? But I honestly think there's other worlds out there that will be life-giving.
Something else that you've looked into in the past is the prospect of space mining. And when we look at other planets, or we look at our moon, or we look at meteorites, asteroids, they're full of quite precious minerals, potentially. And it is, at the moment, a fairly hypothetical theory that we could go and find some of these objects and mine for them and bring back the riches back to our planet. But obviously, you're messing with the cosmos a little bit there, aren't you? But what are your thoughts on it?
Yeah, I mean, this is something I touched on in my first book, Catching Stardust, which is all about comets and asteroids. And actually, the final few chapters, I sort of looked to the future about how we might, first of all, protect our planet from being hit by one of these objects and what we can do about that and how we detect them, but also looking at space mining. Now, space mining, there's a few areas to it, really. We could mine planets like the moon, and I think that probably will end up happening. And I don't know how I feel about that, because the moon is an object we can see. And, it could get, let's say, ruined if we do start mining on the moon. But the fact is, the only way we can get out there and explore the rest of the solar system is probably by getting a base on the moon for humans to live at. And that will require some sort of, change to the lunar surface. But in terms of comets and asteroids, I don't have so much of a problem with us mining those. First of all, because there's billions of them, and we can't see most of them anyway. Like, the only people that can see them are, very clever people with good telescopes. Asteroids in particular are hard to spot because they're very dark. Comets tend to be a bit easier because as they come towards the sun, they light up as their ices start to sublimate off the surface and we see them in the night sky. Most of them are very, very far away from us. They're also really small. So, it's not going to matter if we destroy a whole asteroid that's very small, if it means we can get all the precious metals we might ever need on Earth for, the rest of our lifetime. So, these asteroids have the potential to stop mining on Earth if we wanted. There are cost implications of trying to get up to space and mine material and bring it back to Earth. But these objects are so rich in precious metals that, these are precious metals we need for loads of technology that we use today, including a lot of battery technology that we're going to need in all our cars in the future. We need to find a way to, environmentally safely get this material. And I don't think we want to do that with our own planet. It's very hard to do. So in terms of mining in space, the other thing is we can get water. Comets and asteroids are quite rich in water, and we can use this as rocket propellant. So, and also to support astronauts in space. So I personally really want to see us doing mining in space. And yeah, we've tried it in the movies, haven't we? With Armageddon, and it all looked very scary. But, we can do it robotically now. And there are missions that are now looking at how we can do that safely. There's a lot to think about. We don't want to accidentally divert an asteroid and it ends up on an Earth crossing orbit. That would be a disaster. But obviously, I think we can trust the agencies that are looking at doing this, and we're taking slow steps to try and do it safely. So I'm excited about that field, and I think it's the way forward. But yeah, I don't know how I feel about mining the moon.
Yeah, that obviously is going to be a fairly controversial one, because you won't want to be looking up at the moon to see some sort of like drilling platform there or whatever, and scaffolding and all sorts through a telescope.
Yeah. Or a big open cast mine. I know, it would change it. But I mean, it's whether we need to even go to those extremes. Who knows? I think it's going to be an exciting century, let's say, for whoever's going to survive the next century. I think there's going to be a lot of changes in space exploration. So yeah, we'll keep watching.
I have one more question. And it was something I was thinking about the other day, because I was listening to Adam talking about exoplanets, and I was considering volcanoes, and I started thinking, would we be able to detect volcanic activity on an exoplanet? And if so, what would that look like? Would we just be looking for certain signatures in the atmosphere? Because that is obviously how we mostly detect and study exoplanets. What sort of things would that look like?
Yeah, so first of all, I think detecting exoplanets themselves is incredibly difficult, because the only way we can detect them is by looking at the star they're orbiting and seeing how the light from that star changes as that dark object, which is the planet, passes in front of it. So, we can't directly see the planets very easily. So the next stage is, the next stage we're on to is then looking at those planets and seeing what we can find out about them. So for sure, if we can find out how hot they are, that's going to be a good indication of whether they have volcanic activity on their surfaces. And we think we have found one that's almost like Io, that could be a really, really hot volcanic, and it's a rocky world. So that's kind of the next stage. What is the surface made of, and how hot is it? And then we can start to see whether it could be active. But the atmosphere is also really important. For example, if we can detect water and carbon dioxide and methane in those atmospheres, that can tell us a lot about, whether those materials are being pumped out from the inside of those planets, and whether they could represent a life-giving world. So it's all, deducing it from the data rather than seeing volcanoes directly. I'm not sure when we'll ever be able to actually, take an image of a volcano on an exoplanet. Wouldn't that be amazing? So yeah, we're sort of inferring it all from the data that we get from telescopes. So, but we can still find out an awful lot about those worlds doing that. And yeah, as I said, we think there are some planets out there. And I'm pretty sure, no, I don't know if we found a moon around one, but yeah, we think there's a planet that's like an Io type world. So yeah, that's pretty cool.
Yeah, that would be very, very interesting. I look forward to trying to find the first exovolcano. I guess it would be very interesting.
Natalie, if you were to come to Kielder Observatory, which of course we're in a dark sky park, and we've got a couple of very big telescopes to peer fairly deeply into space. I mean, we can't go right to the end of the universe just yet, but a fair distance. Which would be the first place you would like to point the telescope, and which world would you like to look at for the best view of a volcano?
Oh goodness, that's a really good one. Okay, I'm going to give you a really hard one. I want to see Pluto.
It'll look, it'll look like a teeny tiny little dot. However, it'll be there.
Yeah, I would like, but that would be great, wouldn't it? If we could get a really great image of Pluto from Earth, that would be amazing. Because the New Horizons mission just opened up that world for us, and now it's just so annoying because we can't get back. It's such a long way away. It's like we need better telescopes. Like someone needs to work on that, don't they? So we don't have to go anywhere. But no, I mean, I love looking at the moon as well. I mean, it's just when you get a beautiful telescope image of the moon, it's just fascinating seeing all those features and seeing all those craters that come up, and you get different with the light setting of it. It's just brilliant. So yeah, I could look at the moon all night. It's just beautiful.
Well, thank you very much for joining us in this episode, Dr. Natalie Starkey. It's been great speaking with you and fascinating to get your insight on not just volcanoes, but our own planet, of course, and potentially the search for life. Now, if people want to read more, time for the shameless plug. You do have a new book out, Fire and Ice, The Volcanoes of the Solar System. This has only been released at the back end of September, but tell us more about the book and where people can get hold of it.
Yeah, so my book Fire and Ice came out at the end of September, so it's available in hardback, ebook and audiobook, which I got to narrate, which was an amazing experience of, talking to myself for 3 days. But yeah, that was really fun. So yeah, it's out, and yeah, it's, I think, aimed, really well at a non-specialist audience. So you don't need to have, a huge knowledge about geology or space science or astronomy. It should be really accessible, as is my first book. So I think I've got that market sorted. But equally, if you are a bit of a specialist in some of these areas, I think there's still quite a bit in there that you'll learn, because space volcanoes is not a topic that's covered very often, I don't think. So yeah, it's out. Please buy it. That's what authors always want. Buy our books, please.
No, and I think you've explained it really well as well. I think, as you say, for people who don't have, I think like the majority of people in the world who have an interest in these things, but sometimes it can be difficult to explain it in an everyday kind of sense that people can understand. That's not too scientific, if you know what I mean, and make it approachable.
And I think it's the book I would have wanted to have read when I was kind of starting my A-levels when I was 17, because I was so fascinated by space and geology at that time. And yeah, so I definitely, I would have, I've written it for myself, probably, my younger self.
Fantastic. Well, thanks very much for joining us, Natalie, and the very best of luck with the book as well, which you just mentioned that you can get now. And what, have you got any plans for another book, though? Because I think authors... Once you're kind of in the groove, you can't you can rarely stop them.
Yeah, it's so funny, isn't it? I know I've used up my 2 specialist subject areas though, so I'm going to have to branch out, but I'm quite excited about the idea of writing a more kind of children's focused book on either comets or asteroids or space volcanoes, because I know I can write for that kind of audience, and I love working with children. So that's in my head, but I'm very busy and always like, right, I've got too many plans, but that would be really cool, because I think kids are always excited by space and volcanoes.
Everybody loves a volcano. My thanks to Dr. Natalie Starkey for joining us on the Kielder Observatory podcast. And right now, from other worlds to right here in the northeast, and for a roundup of what's happening at Kielder Observatory as we head into autumn 2021, and a look ahead to the things to look out for in the night sky during October. We speak to Adam Shaw, who is our education lead, and Ellie MacDonald, who's our science lead at Kielder Observatory. Welcome along, and starting with you, Ellie, you are in the process, and we've been talking about this for quite a long time now, in the process of expanding the telescopes that we have at the Kielder Observatory. Obviously, we have the optical telescopes, and there's news about a radio telescope, which has been bubbling away for a little while, and that is taking a step closer.
Well, in the science field, we are still waiting for the radio telescope to be built, but hopefully we will start to see some movement on that, because the laws are relaxing for COVID. Travel restrictions are relaxing a little bit, and now, so long as you're double vaccinated, you can travel without having to isolate in the UK. So hopefully we'll be able to get our team of Italian engineers over soon, and they'll be able to install that and we can start playing around.
And with a radio telescope, it's going to allow us to be able to see the night sky in a whole new way and also be able to see it even when the weather isn't necessarily favourable as well. And as well, of course, being a great addition for our guests, this is also going to provide research opportunities for scientists wherever they may be as well.
Exactly. Radio waves, they're not affected by how cloudy it is, and we're also not affected by how dark it is. So it means during our summer events, particularly the daytime ones with kids and the introduction to astronomy events that we run at the observatory, hopefully what we'll be able to do is we'll still be able to show them things out in the sky, things out in space, galaxies, and interesting radio sources. So things like pulsars give off an awful lot of radio waves, obviously. It's a fantastic way to detect them. And I think pulsars are fascinating. So hopefully we're going to be able to show people them, because we can't show people pulsars through the optical telescopes.
Looking forward to hearing more about this and of course seeing some of the results once it's up and running very soon. Some of the work has already begun. If you do come and visit us at the Kielder Observatory, as you walk down from the car park to the main buildings, you'll see on the left-hand side there's a concrete area that's been prepared, and that's where the radio telescope will sit once the engineers are able to get over to install it. Now, our education lead, Adam Shaw, joins us. Education is something that is a big part of Kielder Observatory. It is an education outreach facility as well as a great place to come and spend your evenings wandering at the night sky, and we do a lot of work with schools. A lot of that, of course, as with everything, has been fairly remote over the last 18 months or so, but some good news on that for you, Adam, that you are now allowed back out again. That's got to be a great piece of news.
That is true, absolutely, yeah. So for the last 18 months, we have been limited to our online delivery, so using video conferencing software such as Zoom or Microsoft Teams and such to remotely go into schools. However, now we can physically go into schools as well. So we're going to be heading into schools, hopefully different schools each week, to deliver a wide range of different workshops, whether it be teaching kids all about astronomy, or different areas of the curriculum within a good astronomy theme, or whether it be getting them to take a look at our space rock collection, our meteorites. They can hold a bit of moon rock or Mars rock inside the classroom and learn about them as hands-on as possible.
And that's really exciting, I think, for kids, or it's exciting for anybody, I think. I think even when you come for a visit to Kielder Observatory, and I've seen grown men excited with the prospect of seeing a bit of moon rock or what have you. And for kids, obviously, it's a big thing. Kids love space, don't they? They love wanting to be an astronaut and all that kind of stuff. And so it's great to be able to take that experience in there in person.
Absolutely. The aim is for us to kind of provide these kids with an opportunity that they may otherwise not have access to, whether it be in school or just otherwise, so we can actually bring a bit of space down into their classroom and hopefully get them hooked in, because science is exciting. Science is awesome. And sometimes it might not come across as being particularly exciting when they're having to learn about not very exciting topics just because it's part of the national curriculum. However, there are lots and lots of different areas of space, of astronomy, that will interest even the least enthusiastic people about space, and by providing as hands-on activities as possible, as interactive activities as possible, we can hopefully kind of get these school children really engaged and really thinking about science as a subject that they enjoy and perhaps even a career path in the future.
Now, if there's any teachers listening to this whose ears have pricked up, and how do they get in touch with you to request a visit from the man himself, Adam Shaw?
So what they can do is they can go onto our website, just kielderobservatory.org, and they can get in contact with us on our website. We've got a contact page. They can provide us provide us all the information. So what school they're from, whereabouts the school is located, what kind of year groups they might want us to get involved with. At the moment, we do have an education contract with the North of Tyne Combined Authority. So that means that any work that we do with schools within either Newcastle, Northumberland or North Tyneside areas can be fully funded. So it will be completely free to the school for us to, for two astronomers to come and visit your school to deliver workshops. And it's an opportunity that you do not want to miss out on.
Absolutely. So there you are. If you are involved with a school in the North of Tyne Combined Authority area, then get a free visit from Kielder Observatory to your school. Get in touch with the observatory to find out more details. Right now, let's have a look at what's in store for October as we move through October and into these autumnal evenings. So what are the things that we can look out for in the night sky, whether you are in a dark sky park or even just in your garden? What are the things to look out for in the night sky this month, Adam?
So the planets Jupiter and Saturn are still around up in the sky. However, they will be disappearing earlier and earlier over the coming weeks or coming months at least. As well as that, the Milky Way is in a good position still. As we kind of get towards the end of the month and kind of further towards winter, we're going to be losing more and more of the Milky Way. However, at the moment, we've still got it rising, sort of emerging from the southeast and stretching directly overhead. You do need to be in a dark location, so far away from light pollution, to really be able to see this up in the sky. And ideally, no moon in the sky as well, because the moon can cause a lot of light pollution as well. However, the Milky Way looks absolutely astounding.
Yeah, it's always a great thing to see, and it's something that we spend a lot of the year talking about, how we look forward to being able to see it. But now is definitely the time.
Absolutely, it is, yes. And there are plenty of other constellations you can spot up in the sky. So kind of just after the sun has set, when it's starting to get dark, and this is our favourite time of the year, because it's starting to get darker earlier and earlier, and that means there's more opportunity to do more stargazing, to do more astronomy. But there are plenty of constellations up in the sky. So directly after the sunset, almost directly overhead, kind of high up toward the south, there's a pattern known as the summer triangle. Now, it's no longer summer, it's very much so autumn now. However, the summer triangle is very prominent. Three bright stars, the stars Vega, Altair and Deneb. So Vega is in the constellation of Lyra the Harp, Altair is in Aquila the Eagle, and Deneb is in Cygnus the Swan. But it makes a great big triangle, and it is most prominent during summertime. But we're only just into autumn, therefore it's still around up in the sky. However, if you're a fan of staying up a little bit later on, there's then the autumn sky emerging earlier and earlier. So we've got constellations such as Pegasus and Andromeda, which will be getting higher and higher as the night goes on. And if you've got a pair of binoculars or a telescope, you can try and spot the Andromeda galaxy as well up in the constellation of Andromeda.
Okay, there's a couple of things to look out for. Ellie, have you got any particular favourite parts of the night sky at this time of year that you like to show visitors?
I mean, loads. Talking about the Milky Way and talking about Andromeda, you need that dark sky for it, and as Adam mentioned, ideally no moon. So new moon this month is on the 6th. So early in the month, nice new moon. It'll be great for Milky Way. It'll be great to have a look at Andromeda, which is really nicely placed right now. But the big thing this month is the Orionids. So the Orionid meteor shower runs through this month. So the tail of Halley's Comet, because it's related to Halley's Comet, this one, that's tomorrow. And then throughout the duration of a month, it will be getting more and more active, peaking on the 21st. Best to view it sort of early morning. So if you're up around 3 a.m., that'll be a good time, 3 a.m. to 5 a.m. And then that'll continue for the rest of the month, trailing off towards the 7th of November.
So eyes to the sky, and you may well see the odd meteor making its way across the night sky as we go through the tail of Halley's Comet, the Orionids meteor shower. Now, as for the events happening at Kielder Observatory over the course of October, as is often the way at the moment, many are already sold out, and you've got to book early. But if you do want to come along and see us, then always have a look online and see if you can get yourself a ticket. But another busy month ahead, Ellie.
Yeah, I mean, plenty for us to do. We're pretty much fully booked up, but if people want to keep an eye out on our Facebook page, then we often, if we get any cancellations, we'll advertise tickets on there. They do go quite quickly, but they come up every now and then, and that's quite a good way to just keep an eye out and book on, maybe if you couldn't get a ticket because they got snapped up so quickly.
Yeah, it does happen quite a lot, actually. We do get the odd cancellation here and there. So if you are nearby and you can make it at short notice, always worth keeping an eye on the social media pages for any cancellations and last-minute availability to come visit us at the Kielder Observatory. My thanks to Ellie and to Adam Shaw, and also to Dr Natalie Starkey for joining us in this month's episode. I hope you've enjoyed it. Now, if you have, that'd be great if you can leave us a nice review on whichever app you're listening to us on. It always helps other fellow astronomers find the podcast and join in the fun. And don't forget to follow or subscribe to us on whichever app you use as well, and that way you'll get the next episode straight to your device as soon as it's available, which will be in the first week of November for the next episode of the Kielder Observatory podcast. In the meantime, keep up to date with everything that's happening at Kielder Observatory on social media. You can find us on Twitter, Instagram and Facebook, and we'll share our photos and videos of things that we spot in the night sky. Keep you up to date with things to look out for as well over the coming month. And of course, as we just mentioned, any details of any late availability should they arise with any cancellations. And of course, you can share your pictures with us in return as well. And keep up to date with everything else that's happening on the main website, which is kielderobservatory.org. And that's the place to go to book your tickets for any upcoming events, either in the near or the longer-term future looking into 2022. And we'll join you again next month. In the meantime, happy stargazing.